Okay, so now this is the same example that we just did, all right? I said that there's two ways you could do step 3, p-values or critical values. Okay, it will be clear in the problem, we'll say which one we want you to do. So last video I did p-values, let us do critical values next. Now your conclusion will not change depending on which one you do. So step 4 and 5, you should get the same conclusion, okay? We'll do critical values right now. All right, so how do you do a critical value? So critical values, instead of looking at your test statistic, right? Well, we still start with the same distribution, right? So we still assume HO is true, and we talk about the distribution of our test statistic, okay? Which is centered on 0. But instead of marking where our observed test statistic was, what we're going to do is we're going to mark where there are rejection regions, where there is a critical turning point. So these values are likely, these values are unlikely. Where does it turn from likely to unlikely? And that is entirely based off of our significance level. Okay? So all critical values will be exactly the same when you have the same significance level and you have the same direction of test. Right? Why do I say direction of test? Well, first off, we're looking at high values of the sample of the population mean. We're not interested in knowing if the population mean is really low. So in this case, we will not have any critical values on the low side. We'll only have critical values on the high side. Now, that's called right tail test, actually, because high is on the right. So this is called a right tail test. Okay? And it's entirely based off of the alternative hypothesis. Okay?
Okay, so it's only because we're saying we think that the income increased
that
we're only looking at the right. But if we had said, oh, I actually think based off of my sample, if my sample mean was, $50,000, then I would say maybe mu is less than, and then I would do a left-tailed test.
Left-tailed test, yeah. Okay. And that will change your critical value, okay? So right now, I'm only interested in having a cutoff on the right side because of the right-tailed test. Make sense?
Mm-hmm.
High values. So this area in here will be our critical or significance level. So 0.05, whatever your significance level is, that's going to be this area here. Anything beyond this cutoff will be considered in the rejection region. Okay, so this area here is called the rejection region. Okay, so now how do I find that cutoff? So I go to my table, and what I want is, I want to find what is this z-value for which the area to the right is 0.05. Now, if I start looking at my thing, remember it tells me the area is to the left. So what should I do?
1 minus.
I should figure out what this is. 0.95, right? That area over there is 0.95. So, okay, so this area, so I should look inside the table and find the corresponding z-value. Okay?
Mm-hmm.
So if I look inside the table, here there's a little star on your table because we have an area that is 0.9495 and 0.9505. So 0.95 is directly between those two numbers. So we take the average of those two different z-values. So that's between 1.64 and 1.65. So this is 1.645. Okay? If you follow that star, there's an arrow on your table. It says z-score 1.645, area 0.95. Okay, so pull out your table and make sure you can see that there too. Okay? Okay, so there you go. That's my critical value. So for all right-tailed hypothesis tests with significance 0.05, that will always be your critical value. Alright? Okay. Now, significance level changes. You have left tail, you got two tail, whatever's going on, things change. Okay, so my observed test statistic So this is your critical value, okay? So that's, if the question is what is the critical value, that's it, right? Now, my observed test statistic is 2.64, which is in the rejection region. That's why I reject the null hypothesis at significance level 0.05, right? So same conclusions. Make sense?
Gotcha.
Any questions about that?
No, that's pretty, yeah. So the p-value, you're finding the area under the curve for your
For our test
test
statistic.
statistic, and the critical value, you're finding the z
Yeah,
for the given area of 5%
very good.
chance. Okay.
Very good. Yep.
Okay.
All right. Let's move on to another example.